Right. So in unit 4, we majorly discuss about the three-phase system. And before introducing the three-phase system, let me revise the single-phase system what we had seen. So in single-phase system, single-phase AC source, and majorly we said that so sinusoidal sources are of our major interest. So we can have the voltage source V of t as Vm sine omega t plus theta, or just simply Vm sine omega t. And these sources are represented by the symbolic representation as sinusoidal symbol inside the circle. And this is what V of t. So, but preferably instead of as a function of time like V of t, Vm sine omega t, we usually represent this in the phasor notation as V bar, which represents that the source value is expressed as V at an angle of 0. Where what is V is that this V bar is the phasor form of the voltage V of t, which is equal to Vm by root 2 is the magnitude and angle of this is 0, which can be written as simply V at an angle 0, where V is the RMS value of the voltage. And if we see the prime like the source nature behind this circuit symbol, how does it look like is that, so for example, if I'll take some magnetic system as like this, certain pattern of the magnetic system. So let us consider that this is certain magnetic system. So in which, just let me complete this magnet. I am taking simple magnet which is cut into this shape. There is a particular shape. Let us say this is the shape of the magnet. It's not so good. And apart from that, just let me take on top of this one circle, or just let me take a side and select. See that you will see some interesting things here. See that this is certain magnet. So let me highlight the magnetic portion, which is very important for us. So I'll take this. Usually let us take the, sorry, let me take the magnet in this way. Just I want to shade this portion. Let us see how does it look like. See that this shaded region is what the magnet. Remaining things is not the magnet. So we cut the magnetic piece into this shape. Simple magnet into this shape. So when we have magnet, you might be studied in generally that it forms north and south poles. It forms north and south poles. And one should understand the basic magnetic systems that the flux lines will emanate from the north pole and reach to the south pole as like this. These are what the flux lines in any magnet. The flux lines will originate from the north pole, terminate at the south pole. Now in this kind of system, if I'll place one conductor as like this, conductor is one wire. But instead of taking one conductor, what I'll do is that I'll take two conductors in this shape and I'll try to connect these two conductors ends one side here as like this, and this other side I'll bring to some shape with the end terminals as starting terminal as A, ending terminal as A dash. So this has basically two conductors. One is this one. Let me highlight the portion of that. The conductor portion. This is one conductor. This is one more conductor. Means wires, two wires. So the formation of two wires, what does it gives is coil. This we call as a coil. Now, what is our main motto here is that just to illustrate the Faraday's law. Faraday's law. Faraday's law. What is Faraday's law is that, so in order to deal the Faraday's law, we need a coil and we need some magnetic field or the flux lines, field lines, field lines. These are the two interesting things to discuss about the Faraday's law. One is coil, another is field lines or flux lines. Now, what is the phenomena about the Faraday's law is that when we see the relative velocity between these two quantities, these two items, relative velocity, relative velocity. What does mean by the relative velocity? Means that coil can be rotated and field lines might be stationary, means just it's not moving. Then you can see certain thing is moving. That is what relative velocity. One to another, definitely there must be velocity. Both should not be stationary. Any one can be moving, other can be constant. Like that, if it has any relative velocity, then according to Faraday's law, it states that EMF is induced, EMF is induced in a conductor or coil, in a coil. This is what the basic idea of the Faraday's law. Now just we would like to incorporate this Faraday's law over here, for which, so I already taken the magnetic system, where magnetic system consists of a magnet which is cut into required shape. So which is producing the magnetic field. So the field lines are represented over here as green color. In this magnet, I want to place this coil. So how I will place? Just check it. So this is one side conductor. This is one more side conductor as like this. And these are extended terminals. And starting terminal of the coil is A. Ending terminal of the coil is A dash. And other side it is joined like this. This is one coil. Now if you assume that somehow we could able to rotate this coil about this axis, if we rotate this coil about this axis, let us say in certain anti-clockwise direction, if I rotate this at an angular velocity of omega, if we rotate this coil at an angular velocity of omega, then if we measure the voltage between A and A dash, what kind of voltage we get is that sinusoidal voltage which replicates the form of Vm sin omega t, Vm sin omega t. This is what the sinusoidal voltage developed between the terminals of these coils. And this voltage which is induced between A and A dash, we are representing this entire system as simply one source symbol as like this. So if you see behind this source, what was there is that we have a coil, and coil is rotating inside this magnetic field at an angular velocity of omega in anti-clockwise direction. As a result of this motion of the coil, relative velocity is created, thereby it is inducing EMF inside this coil. If we measure that inside induced EMF of this coil, it has the following shape as Vm sin omega t format. And that is what our voltage basically. And which we call this as a single phase voltage, where one of the phase is A, one of the phase is A. That phase means one coil. Phase means one coil. And other side of the terminal is A dash. As like this. See, one side is A, other side is A dash. Then inside this circle, what was there? This entire magnetic system, inside which this coil also there. That is what the generalized thing. Every time we cannot represent this entire system. Instead of that, simply we represent the single phase source as like this. Now, let me introduce one more thing, that instead of one coil, instead of this kind of one coil, what we do is that three coils we choose in generating the voltage or EMF simultaneously at a time. At a time, what I need is that, so already one coil is placed inside this magnetic field. What we try to do is that I will try to take two more coils as like this, as like this. So where if this coil is placed somewhere here, what I will do is that I will try to make some angle with this, and from here I will try to take one more coil as like this. This is one more coil which is tilted by certain angle with this A dash. Let us call this as B dash. Similarly, let me choose one more coil which is further tilted from this coil as like this. Right, so as like this. See that one to another there will be certain tilting, means some rotation was there. This is, let us say, CC dash. Physically these have certain displacement. Now if A coil is rotating, it produces some induced EMF. Then along with the A coil, B coil also rotating and C coil also rotating. Now what happens is that depends on the its displacement, that at which the coil is placed. For example, if the A coil voltage is V A dash, which is equal to Vm sin omega t, which is equal to Vm sin omega t, which is producing a phase angle of 0. Now, just try to observe, if I will measure the voltage in B dash coil, so let us assume that same kind of magnitude which is Vm, same kind of sinusoidal which is sin omega t, but this second coil has a certain lag, like as I introduced previously, lagging leading concept, that means this person B dash coil is lagging A dash coil physically over here by certain angle, let us say, which is 120 degrees. So its corresponding voltage also which is induced inside this coil will lag the first voltage by 120 degrees. In the same way, you can think of that third coil is also further lagging the corresponding B dash coil by 120 degrees. So 120 further from here is, so you can write this as minus 240. So like this depends on its physical displacement. The voltages produced in each coil going to differ by certain angle. So that is what the phase. See that first coil voltage is producing at 0 degree onwards, whereas second coil is producing from 120 degree onwards, and third coil is producing from 240 degree onwards. Now if you plot all these three, you will get very interesting nature. Let us see that how does it look like. Let us take these three voltages, and let us plot these three voltages. Let us plot these three voltages. So we already seen so how to plot the sinusoidal voltage previously. So now let me take in this way that, so this is, let us say, omega t axis when omega t is equal to 0. So first A waveform, so it look like rising, decaying, and decaying negative maximum, and like this. So this same copy is going to be repeated once again as like this, and one more cycle also going to repeat it as like this. This is what V A dash. So it will become clumsy, so I am not representing. You should understand by this color things clearly. So next let me take the second one. See, when omega t is equal to 120 degrees, that means this is, let us say, 60, 120, 180. So this is what 120 degrees, this is 60 degrees, this is 0 degree. Then 180 plus 60 is, let us say, 240, and 270, 360. This is what 360. So this is 240 plus 6, no, 210, I think. 180 plus, no, what I am doing, 60, 60 we need to add. Yeah, 240. So plus, yeah, 60, 300, right, right. We are adding 60, 60. So that means I am dividing this time axis into 60, 60 degree position. The entire 360 is divided into these kind of things. Now see that second waveform, when omega t is equal to 120, sine will be 0. Yes or no? Sine of omega t means 120 minus 120 is 0. So from there onwards, this sine is developed as like this. As like this. So then this will continue. So like how long? To, so up to here, that means, so I hope this is at 300, then followed in this way, and so on. So you can interpret now by this time. So let me not to continue further. Next is this one, omega t minus 240. That means this will start from 240. So how should I draw? As like this. 240 to where? 180. 240 plus 180. How much is that? So till that angle it will goes. 240 plus 180. Something as like this. The wave nature will look like this. So now try to observe that each thing which has minus 120, minus 240 or something angle, those are lagging the first waveform. That means those are starting with certain delay introduced by these angles. Okay, so that much you try to understand. That, so first waveform who has come and occupied their seat is started early, and second person so has occupied with certain distance, so in order to reach to the first person he will have certain delay, so that delay is 120 degree. So how does it look like is as like this. Just let me show those things here so clearly. For example, if the first coil is like this, first coil is something like this. Just I am not showing entire magnetic system, and even this extension is not required, it become clumsy. This is first coil, red coil. Next is, let us say this orange or yellow, whatever you can understand, is having this kind of nature, whether it conveying properly or not, I don't know, but let me place a little different way as like this. So just let me place the red line, once again these things. If it has some tilt, it look like 3D view. So just I want to produce that how exactly it look like is that. So now let me take this second coil. I hope now it gives some sense that how it look like. So this red color one is horizontally on the plane, means on the paper, whereas this second color, that is orange color, is tilted by some angle. How much is that angle? From this plane is 120 degrees. And further, the last one is as like this. I hope you can understand some extent whether it's conveying or not. You can see that now each one has 120 degrees difference from one to another physically. So thereby these three coils are producing EMFs or induced EMFs, which is voltage. So VAA dash, BB dash, CC dash, which look like this. Now if I'll express these three things into phasor form, so you can see that how it look like. So let us say
It's in
V.
120 degrees difference the move అవుతుంటది సార్.
Yes. If we place, so first coil at 0 degree position, it is producing from 0 degree onwards. If the second coil is tilted by 120 degrees physically from the paper, like if this is the screen is the paper, from there it must be tilted by 120 degrees. Okay. So then that corresponding induced EMF also delayed by 120 degrees like that. Okay. Right. So now if we express these things into some phasor form, A dash phasor, can I write as magnitude is Vm by root 2, angle is 0. So which can be written as simply VA, means A corresponding coil voltage at an angle 0, where A corresponding voltage VA magnitude is equal to Vm by root 2. Vm by root 2. Next is V BB dash voltage is equal to Vm by root 2 at an angle minus 120, which is equal to, let us say, VB at an angle 0, where VB is equal to the magnitude of the voltage, which is equal to Vm by root 2, and so on. VCC dash is equal to Vm by root 2 at an angle of minus 240, which is equal to VC at an angle 0, where VC is equal to Vm by root 2. Now let us see the interesting thing that if we have one coil as like this, that is what responsible for producing this induced EMF, one induced EMF. So we call this as a single phase system. Single phase system. Now if we have two more such coils, then those two more such coils also producing the induced EMF as like Vm sin omega t format. Now all together we call this as a three phase voltages. Three phase voltages. Three phase voltages. Now if you see these three phase voltages, one can name these voltages as A coil voltage, B coil voltage, C coil voltage, which is simply which is simply named as like this. So A phase voltage directly one can call as VA phasor. That means A dash voltage is what VA. B phase voltage can be called as VB and C phase voltage can be called as VC. So this is what ABC. Three coils whose name is ABC. Or one can even call with some color coding as R phase voltage. R is equivalent to A and Y phase voltage where Y is equivalent to B. So our B phase voltage, which is blue, blue is equivalent to C phase. So we may use either of the notation, that you should understand. Okay. So we can utilize either of the notation. Preferably we use this color coded notation as R for red color, and Y for yellow color, and B for blue. These three color coding we use to represent the three phase voltages. Three phase voltages. Even you can see outside, if it is like distribution panel board, you can see color coding R, Y, B like that. Okay. So now let us try to understand these voltages and the rest of the concept. So what we do is that these three coils which I shown here look like very complex section. Now instead of this kind of complex representation, what we do is that I will try to make certain connection as like this. See how I will make the connection is that you already seen we have three coils. Let us say first coil is R coil. R means red phase coil, which is equivalent to A dash. Now let me leave or just for the timing some more time let me use the same notation. Uh, it's your wish. Otherwise, let me directly jump into color coded notation as R dash means red color R dash. You can use equivalently A dash also as like this here. Whatever I had shown. A dash, B dash, C dash. Okay. So second one is, let us assume this is yellow color. So yellow color does not give the proper visibility. So I am taking orange is equivalent to yellow. So now where I am placing this coil is certain tilting in this physical space that as like this, whose terminals are Y dash. And one more coil I am placing over here, which I will call as blue corresponding coil, which is B dash. These are the three coils. Now, so we have certain physical system as like this, which is 360 degrees of circumference. Now, what I would like to make is that, so this 360 degrees space distribution I want to balancedly allocate for these three coils. So I will place one coil at one place. Then after 120 degrees I will place second coil at that location. Then after 120 degrees further from there I will place the third coil. So now you can observe that. So the angle from one coil to another coil is equally balanced. Here is 120 degrees and here to here is again 120 degrees and here to here is again 120 degrees physically this much angle is there. So like that I placed R coil here, then Y coil, then B coil. Now what I will do is that I will try to join these all three by some wire, that is R dash, Y dash, B dash terminals I joined. Now could you see this pattern? We had already seen this kind of thing. Is it looking like star connection? It is a basically star connection. Now what are we doing is that these three coils, we can make a three-phase generator with the connection as a star. Now, if I'll take up this entire thing as a generator, now try to observe. Let me extend these terminals. This is what R, this is what Y, this is what B. So these are the three terminals. Now let me place these things inside the dotted box. Inside the dotted box. This inside the dotted box is what the three-phase generator, or you can call this as a three-phase source. This is simply three-phase source, or you can call as three-phase generator. Okay. Now try to observe. So the voltage from this R2 common terminal, that is R2 R dash, is what the voltage VR. And so let me write that, just for the sake of this, I will be taking this common terminal also outside, and I will call this common terminal as N, where this N represents neutral. Now, if I'll measure voltage from R to N, how much is the voltage? VR. That is R to R dash voltage is VR. You can check here. R to R dash is nothing but A to A dash. Okay, that is what the VR. Similarly, Y to Y dash is what? VY. But where is Y? Here. Here is Y. Then Y to Y dash is what? VY. See that how the arrow look like. Arrow is pointing towards that corresponding color coded phase, which is Y. N is neutral. Next is last one, blue. Blue is from neutral to this blue color line is what the B phase voltage, which is VB. So these we call as a three phase generator voltages, which are R, Y and B, and whose magnitudes and angles I already defined over here, and in which try to observe all the voltages magnitudes are equal. Let me define in this way so let me use the color coding, that R phase voltage VR is equal to so as uh, uh, right so as V at an angle 0, and or yeah, so let me use for the timing VR also, and Y phase voltage as VY. Just I am writing same thing with different notation, that's all. You should be in a position to understand whatever may be the notation. So it has magnitude and angles. Sorry, this should be minus 120, this is minus 240. Okay, now just try to understand that. So these voltages has the pattern as its magnitude and angles. If you observe the angle nature from one to another, that is R to Y, Y is at minus 120, B is at minus 240. This is the generalized pattern, try to understand. If for example, if I will be sitting over here, then my position, if I will consider as 0 degree, from there, then you look in the backward direction, which is negative angle direction. So one more person, which is your friend, might be sitting, and definitely he might be having lesser degree in comparison to me by 120 degrees, that is minus 120. And further, if one more friend of you might be standing over here, but he is further lagging you by 120 degrees. This is further minus 120. So minus 120 minus 120. Total is 240. This third person is lagging you by 240 degrees, whereas the second person lagging you by 120 degrees. You are at 0 degree. That is the way you need to understand. Clear? Right. Now, here let me introduce one more interesting thing, and which is very important, that so balanced system and unbalanced system. As because we have three voltages, so let me write balanced and unbalanced. Unbalanced. Simple. Balanced means that, see, every phase voltage has magnitude and angle, magnitude and angle, magnitude and angle, magnitude and angle. If these are balanced, then it is called as a balanced system. Balanced in the sense that all the voltage magnitudes must be same. VR must be equal to Vy must be equal to Vb, which is equal to, let us say, V, or Vp means phase voltage. Vp means P represents phase. Okay. If all magnitudes are same, then angle from one to another is 120 degree, and phase angles or with a difference of with a difference of with a difference of 120 degrees from one to another, from one to another. So this you should understand. For example, if I am the first person as like this, if I'll see my next friend, is he having 120 degrees difference from me or not? That is fine. Second person is over. Now, if you look from the second person, is the third person is having further 120 degree from this second person or not? If these two are having 120, 120, obviously third person with the first person will have definitely 120 degrees. Why? Because here 240 gone. Left out thing is, so 360 minus 240 is what? The 120. So in this way, if those are sharing that entire 360 degrees in a balanced manner, that the one person to next person and next person to further next person, if it is having a difference of 120 degrees, then it is called as a balanced system. So this thing you should understand carefully. Magnitudes must be equal for each phase, and angles from one to another should be differed by 120 degrees. Now, unbalanced means if any of the condition here which we specified is violating, that is what the unbalanced. Unbalanced in the sense that if VR is equal to Vy but not equal to Vb, then it is unbalanced. So it has 120 degrees, but if one of the magnitude is not equal, then you can call that as a unbalanced. So let me say that if it fails, if it fails to satisfy balanced condition, then it is called as unbalanced. Unbalanced. You should understand this very carefully. For example, as like, if angle, like, let me show directly voltages as like this. VR is equal to V1 at an angle of 0. Vy is equal to V1 at an angle of minus 120. Vb is equal to 2V1 at an angle of minus 240. Is it a balanced or unbalanced? Angles are C, 120 degrees. So balanced. But what about magnitudes? That is very important. See that this magnitude is V1, fine. This also V1, fine. But this is 2V1. That means all magnitudes are not same. So this is the reason that it is not balanced. Got my point? Two voltage magnitudes are equal, but third voltage magnitude is double of these. So which is not balanced. So magnitudes must be equal, angles must be differed by 120. If this condition violates, it is called as a unbalanced. Clear? Clear? Right? Okay. So now let us see one more interesting thing, which is the phase sequence. Phase sequence. Sequence means just which comes next. As like in the seating order, if one person is like people are sitting in a sequence manner, 1, 2, 3 like that. So let us see how the phases are sequenced here. And for which let me take again this diagram. So I can choose this diagram, and we can just have the analysis in this way. To understand the phase sequence, simple thing. So let me remove these portions as of now. These are not required. Now what we do is that we will assume ourselves three persons. We are three persons. Okay. So one is here, one is standing over here. Okay. Person number one. Person number two is standing here. This is the second person. And person number three is standing here. Okay. So we are three persons. And so this entire box is what the generator. Generally you can simply understand that generator or motor, something is rotating, right? When you see outside, inside that some shaft or some rod will be rotating. That means inside this generator, this entire structure is rotating. How it is rotating? Let us say in anti-clockwise direction, as like this, at an angular velocity of omega. So rotating, this entire structure is rotating at an angular velocity omega in anti-clockwise direction. That is our reference direction. Okay. So this is what our reference. Mostly in any electrical system, we consider anti-clockwise rotation as a reference, which is positive rotated direction, for example. Now try to understand clearly. You take some reference somewhere here, somewhere just some fourth person, somebody observing. Let us say you are three students. So myself, just I came and started observing by sitting over here. So from here, I am observing. As this entire structure rotates, who is crossing me first? That I am trying to observe. I am sitting over here. And first, this first person will come, yes or no?
Yes, sir. First call rotator.
So definitely first person will cross me, then he go away. So that is what the first person, let me say first person. After first person, who comes? Who will come in the next
Second one.
sequence? Like who will cross me? Second.
Second person, sir.
Let me use color coding also. Second. Then second followed with third.
Third.
Third person, sir.
Then after third, who will come again? If this continues, if this
First
rotation
one, sir.
continues, if this rotation continues, just think that again first person will come. And if it continues, then second person, then again third person, and so on. This will keep on continuing. This is what the phase sequence. So instead of first person, second person, what I'll say is that R phase is what the first person, whose voltage is VR, or you can also call ER, induced voltage. Second is VY, third is VB. So now in the form of phasors, as like in the form of notation as RYB, So how my phasors look like is that, now let me proceed in this way. First is R followed with, or let me write as it is first, followed with Y, then followed with B, then followed with again R, then again Y, then B, and so on. This will keep on repeats. Now in this, so I can choose anything as like this set of things, that R, Y, B, or you can also choose Y, B, R, or you can also choose B, R, Y. In any form, this is what the positive phase sequence, positive phase sequence. What is positive phase sequence is that when generator is rotating in anti-clockwise direction, the sequence of the phases which comes is referred as positive phase sequence. When the generator is rotating in anti-clockwise direction, the sequence of the phases which comes one after other is referred as positive phase sequence, which can be named as simply RYB or YBR or BRY. All are same. Don't say that, so this is positive, this is negative, this is something else. No, all are same. Why? Because these sequence are coming when it is rotating in anti-clockwise direction. Clear? Now instead of these many, this kind of thing, what I will do is that just I will try to put on a circle as like this. So if the R person is standing over here, then Y person let me put over here, and B person let me put over here. Now in between, just I will try to add some things as like this. Okay. Now try to see if this structure, if these things are rotating in anti-clockwise direction at an angular velocity omega. So whatever the sequence comes, that is what the positive phase sequence. Like if I'll stand over here and see Y, B, R, or if I'll stand over here and see B, R, Y, like that, some sequence will come. Then what is the negative phase sequence? What is negative phase sequence? Is that, so again same thing, just let me say in a simple terms that when these phasors are over here, negative phase sequence means when the things are rotating in clockwise. As I told you previously, if this is 0 degree, anti-clockwise direction we call as positive angle direction, clockwise direction we call as a negative angle direction. This negative angle direction when system is rotating, now what kind of things I will come across? Tell me. If I'll,
RYB.
exactly, if I'll sit over here, then first I will see R, first I will see R, then followed with
Right.
B.
B, sir.
See here, if I'll stand over here, just try to understand carefully. If I stand over here, then first I'll see R. If it is in clockwise, then next whom I see? B.
B,
Then
sir.
next whom I see? Y.
Y, sir.
So then after that, again
R, sir.
R. Like that, it will continue. Okay. So this is what the negative phase sequence. So
సార్ క్లాక్ వైజ్ కదా ఆర్వైబి వస్తుంది కదా సార్ ఆర్బీవై కాకుండా.
no, see, this is the stationary object. This is myself. So, like, just try to understand. I am standing over here. This is rotating. Okay. You can take some circle kind of thing which is rotating, and beside that, you stand stationary. Here I am sitting, and this is rotating. How? In clockwise direction. As it rotates in clockwise, just you can take in watch also. After, if this R is moving in this direction, that is simple thing. You can understand, right? If R is going ahead, who is coming and occupying this position? Next is B, right?
Yes, sir. Okay.
This entire thing you assume as some ring. Okay. This ring is rotating. How it is rotating? In clockwise. If it is rotating, what you could see after Y? R after R, B, then after B, then Y, like that. This also a ring which is rotating in what direction? Counterclockwise direction. Then if somebody is standing and sitting over here and checking that who is coming first, etc., like in this competition, then what he could see as this ring rotates in counterclockwise direction? RYB. So usually RYB is referred as positive phase sequence, this one, and RBY is referred as negative phase sequence. Negative phase sequence. So usually, so for example, if I will give you the voltages as like this, or just I will write directly like this. Let us say all the voltage magnitudes are same. VR is equal to Vy is equal to Vb is equal to V. Now what extra they will give is that phase sequence is positive phase sequence. Positive phase sequence. Now I could produce with the help of these 2 points the voltages. With the help of these 2 points, the voltages as like this. I can say VR phasor is equal to magnitude is V. If I'll assume this itself is the reference where I am sitting, I'll call this angle as 0. The next person who is coming is in the positive phase sequence. Who is the next person? Y. RYB is positive. You should understand that. Okay. So next person is Y phase whose magnitude also same, but how much is his angle?
120, sir.
One.
Minus 120. Okay. Next is, so B whose magnitude also same, so minus 240. This is the positive sequence voltages for balanced system. See, voltage magnitudes are same. That's why I am calling as balanced system. Now in the same way, in the same way, in the same way, if I'll consider negative phase sequence, let me show that part. So what I'll do is that negative phase sequence. Negative phase sequence means you should understand that R, B, Y in a simple terms. So now tell me, so if R is taken as reference 0, who comes next?
VB.
B, whose magnitude is same but angle is now minus.
Minus
Minus 1.
120.
After B, who comes? Y.
V. Y, sir.
Y, sir.
This is what the negative phase
Minus
sequence
2.
voltages. Okay. So in the question or in the data they will give that whether it is positive phase sequence or negative phase sequence. Depends on that. Once magnitude is known, one magnitude is known, you can write remaining two magnitudes and angles for balanced system. Okay. So finally just let me give you some simple thing that just to identify how well you understood that. So I'll give in this way that, so like some voltages VR is equal to, so 20 at an angle minus 20 degrees, Vy is equal to, so 50 at an angle like plus 120 degrees, and Vb is equal to some 100 at an angle of, so something like minus 280 degrees. Identify what is the phase sequence of these voltages. It doesn't matter whether it is balanced or unbalanced. Each one has its own phase sequence. Okay. So first thing you should observe here is that it is a unbalanced system. Yes or no?
Yes, sir.
Yes.
Why? Because
Right.
magnitudes are not
Magnets are
same.
different, sir.
Not only that, angles also not differed by 120. See? Okay. Right. Next, simply what we do is that we try to produce this kind of circle in the form of phasors as like this. See, I will try to assume simple alpha beta axis as what I introduced previously. Alpha is 0 degrees, this beta is 90 degrees, this is 180 like that. So let us put all these phasors in this spatial plane. VR is having magnitude of 20 but angle minus 20. Where minus will come? From 0, if I will move clockwise by some angle, there I will get as with this much length, this is what 20 units of length, but angle made by this from here is what the 20 degrees. This is what VR. What about Vy? Vy is plus 120 from where? From 0. Plus means what? Counterclockwise direction. This is positive angles direction. From here, I need to move 120 degrees. So after 90, I will get 120, right? So how much is its length? 50 units. This is what Vy, whose angle is 120 degrees. From where? From 0. What about B? B units length is 100 but angle is minus 280. Minus angles are in clockwise. So if I'll move from here to here, I'll get 180. But still I did not got 280. So I need to add 100 more. Means this is 90 degrees. Then after that I need to add 10 degrees. So it becomes 100. So 180 plus 100 is 280. That means I need to travel this much in which direction? Negative angle direction, which is clockwise. There you put one vector of length 100 units. So this entire thing, let us say, let me write here, this is 180 and this is 110, right? No, 100. 90 plus 10 degrees, 100. So 180 plus 100 is 280, which is clockwise, so negative angle. So this is what? 100 units. Now see, simply, so just think that somewhere, it doesn't matter, somewhere, so just some responsible person who want to count that is standing here. And what you need to do interestingly is that assume that this entire system is rotating in which direction? Tell me, which direction? We said that this entire thing you can assume as generator. So assume that this entire system, that is R phase, Y phase, B phase, is rotating in counterclockwise direction at an angular velocity omega. Now you look for who is coming first. Then after that next who will come, like that. These phasors, if it is rotating in counterclockwise direction, so who will come first is R, then Y, then B. Yes or no? Got my point? This is very interesting and very important. If this entire phasors are rotating in counterclockwise direction, first I could see R phase, then I could see Y phase, then I could see B phase. This is what RYB, so positive phase sequence. Got my point? Okay. So just plot the given voltages on phasor diagram. Then try to rotate that entire phasors by counterclockwise direction. And take somewhere a reference as like this.
సార్ కౌంటర్ క్లాక్ వైజ్ అని చెప్పి ఎలా చెప్పారు సార్?
That what I said here. Generally, all generators will rotate in counterclockwise direction. That's why our reference itself is counterclockwise direction. If it is rotating in counterclockwise direction, if I could see RYB, it is positive. If I'll see RBY, I will call that as a negative phase. Okay. So that is
ఓకే సార్.
the way of identifying the phase sequence. If you want, just let me give quickly one more example. So as like certain balanced kind of thing, let us say, so 100 at an angle of, so minus 120 degree, and yeah, so one more is 100 at an angle of uh, 0 degree and 100 at an angle of plus 120 degree. Okay, so let us say VR, VY, VB. Otherwise, let me say extend VB, VY. Now tell me, so what is the phase sequence, positive or negative? So what I will do is quickly in this way. R phase voltage is at 0. This is what VR. VR means 100. Angle is 0 degree. And Y is plus 120. Plus 120 means somewhere else here. Here to here is plus 120. This is also 100 units. And B is minus 120. Here to here is clockwise is negative angle. Anti-clockwise is positive angle. That you remember. This is also 100. Now somewhere, anywhere, it doesn't matter. So you take some reference, either here or here or here, anywhere. You stand there and you ask to rotate this guy now. These three are simultaneously rotating. How? In which direction?
Anti-clockwise direction, sir.
Anti-clockwise direction. Now first what I'll see, if this is the person, I'll
R, sir.
see R, then B,
Y.
then no. Counterclockwise, right?
Yes, sir.
I am not rotating. This is stationary. What is rotating is this thing. So I think people are getting confused with this. This is a ring. Now this ring is rotating. How? How it is rotating? In
Anti-clockwise direction,
anti-clockwise
sir.
direction. So if it is rotating in anti-clockwise direction, what I will see first? R,
R.
then B, then Y.
Okay, sir.
That means R, B, Y. What is the phase sequence? R, B, Y means negative phase sequence. Got it? Okay. Negative phase sequence. Clear? Is this clear? So in this way you can identify so whether things are positive phase sequence or negative phase sequence. Clear? Thank you.